Okay, this question talks about figure 1 printed on the insert. All you need actually is a sheet of graph paper because we're just going to be plotting this data. Yeah. In fact, in part A, it says plot a scattergram of the diagram of these data. We know what X is, we know what Y is, so this will be the independent variable or the explanatory variable. This will be the response variable or the independent variable. So this goes on the X-axis, this goes on the Y-axis. Okay, plot your scatter diagram. Okay, then we've got to calculate the equation of the least squares regression line. Okay, so in your answer you're going to be telling me that A equals and B equals, but you're also going to tell me that Y equals something plus something times X. So you haven't got the regression line until you slotted your A and B values into the equation. And then you've got to plot this graph onto your diagram. So to do that, you're going to take two X values and plug them in. So you've got two X coordinates, and you're going to need to find the Y coordinate for each X coordinate. Okay, so the X coordinates you should choose a small x and a large X. Okay, they don't have to be ones from the table, but they do have to fit on your scales. Okay, so depending on how you've set this up on graph paper, yeah, you probably have started your scale at 0 because we've got a quite small value here. You've certainly gone beyond 1,000. So you could take, as one example, you could take X is 0 and X is 1,000. And work out from your equation what Y values go with those. Then you plot these 2 points you found and join them together with a straight line on your graph paper, and that will complete these 6 marks, which should be very easy. Okay. Then we've got to find a residual. Now we've got to remember what residual means. Residual means something minus something. Make sure you know which way round it is. One of the things is going to be the prediction from the regression equation, yeah, which you can also read off from the line. Okay, and the other one is going to be the actual value, the observed value from the table. Okay, and the way around that you calculate this, we've got data for customer H, is it's always actual minus the predicted. Okay, so if you don't know that, learn the order of that subtraction. Okay, so the actual value of Y for H is given here. You're going to take away the predicted value of Y, which you should get from the regression equation by substituting the X value in. Okay, it is possible to take a reading off your graph as well, but this is a more accurate way of doing it. Okay, we need to, so having done the calculation, in fact this makes it very clear, we want to calculate the value of the residual, so you do have to do it with the equation and the value from the table here, but then we need to show on the scatter diagram the measurement you could take, so you need to show how that value of the residual shows the distance above or below the regression line that you are. So you need to add a line on your scatter diagram to show that distance and label it. And then for part D, okay, we've got his charge per hour, and we've got to estimate the charge for mowing a lawn with an area. So we've got an area, okay, and one of these, X or Y, is an area, okay, and we can use that to predict what, well, Y, okay, is the number of minutes that he takes to mow these lawns. So for this one here, we should be able to say that 560 meters squared, okay, we should be able to use our regression equation to predict how many minutes. So there's going to be some number of minutes. Show your method obviously for this, don't just write down how many minutes, show how you work them out as well. Okay, and then if we know how many minutes it is, and we can just do ordinary calculations with £12 per hour to give a final answer. So after some working, your final answer will be his bill in pounds. Okay.